I saw this integral on YouTube. It's not an easy one. I have my way of doing it, so I want to share with you here. Now I start with completing the square for the denominator. That is x plus half square and plus 3/4. Okay, that's easy to understand. So this is sine x dx. Then I use substitution. I bring t, let t be the x plus half. Okay, that is my t. So my integral becomes sine x will be sine t minus half, right? And this will be t squared plus 3/4. And dt is dx. And the boundary no change. So this one is equal to integral t squared plus 3/4. And this will be sine t cosine half minus sine half cosine t and the dt. Now here I have two integrals. This is one minus this is the other. Now this integral, this constant, this is a square, this is odd function. So in this interval, this integral is 0. So left over is negative sine half times integral cosine t squared plus 3/4 dt. Wow, a little better. I call this integral j minus sine half times j. Well, I just discussed j separately. Now, to do this integral, I'm using Feynman's technique. So I introduce a function f of a is equal to integral for this integral is a cosine at t squared plus 3/4 dt. Yeah. So here, my f of a 0, f of 0, this is equal 1. This is 1. dt over this, that is easy integral. This is a root 3 to line arctangent 2t over root 3. Okay. So, which means that f of 0 is equal to 2 pi over root 3. So this is my initial condition. And we are looking for f of 1, right? Now then, when start the derivative of f with respect to a. So that would be the derivative with respect to a here, the partial derivatives. That is that t is constant, a is variable. It is a negative sign at, right? Negative, and then multiplied by t because a is variable, t is constant. Okay. Then I multiply t both top and the bottom. This one equal to negative r times t, r times t on top become t squared, right? So sine at, this is t squared after times t, okay? So this is t squared plus 3/4 minus 3/4. That is still t squared. Yeah. So I have two integrals. This is one minus this is the other. And this integral, after cancel this, right? It becomes, the first integral is this, sine at dt. This is cancel out, is a t, right? The other one is become plus, negative plus integral sine at from minus infinity to positive infinity, and then t square plus 3/4 dt. Yeah. For this one, I can multiply a here and times a there, right? So this one is a sine at dat over at, right? Yeah, sine at over at dat. That is a well-known integral, the Dirichlet or something like that. So it's equal to pi, right? Yeah. So this one equal to negative pi. This is pi plus 3/4 integral sine at t square plus 3/4 and the dt. And that is what? That is the first derivative. F prime of a is this. Then therefore, the double prime, the second derivative of f with respect to a, well, this will be 0, right? This is 0. And the plus 3/4 integral. Yeah. Integral, this is a cosine at times t, right? Because t is a constant. T times t squared plus 3/4 and dt. Well, t and t cancel out. So left over is 3/4 of f of a. f of a. See, that's f of a, right? After t cancel out. So f of a. So this becomes a differential equation of second order. So that means that f of a equal to uh, f of a equal to c1 e to the root 3 over 2a plus c2 e to the negative root 3 over 2a. So that is the solution to this equation, right? F double prime of a. This equation, differential equation, second order, the solution is this. Okay, good. Now we can continue. Well, we are solving this equation, okay, by using initial condition. The first initial condition is this: f of a 0 is equal to 2 pi over root 3. Okay, that is one. The other one is this: f prime of a equal to this. So f prime of a 0 will be equal to this 0, right? When a is 0, so equal negative pi. So that is another initial condition. Now then we can find the solution, which is when a equal to 0 is 2 pi over root 3 is equal to c1 plus c2. So that is equation 1. Now equation 2, we take the derivative. This is f of a. F prime of a will be root 3 over 2 c1 e to the root 3 over 2a, and this will be minus root 3 over 2 c2 e to the negative root 3 over 2a. That is this derivative with respect to a, right? Now then we're using this initial condition coming from this equation. So which means that negative pi is equal to, no, let me write the equation first. This one implies this is 0, therefore equal to 1, therefore being root 3 over 2 c1 minus root 3 over 2 c2 is equal to negative pi. Wow, that is equation 2, right? Equation 1 and equation 2. And equation 1 and equation 2 give a solution. Uh, give solution that c1 is a 0. Yeah, this one. Move over this equal to, when you add up equal to 0. Yeah, c2 is equal to what's a c2? C2 is equal to 2 pi over root 3. This is c2. Therefore, my f of a is equal to this, right? 2 pi over root 3, that's C2, e to the negative root 3 over 2a, yeah. Now, what is our j? Our j is equal to f of 1, right? This is j. When a equal to 1, that is our j. So j equal to f of 1. This equal to 2 pi over root 3 e to the negative root 3. This is my j. Then I plug this j into this, I get my I. Okay, this is my initial I equal to sine half times j, negative. So my I is equal to negative sine half times j. So I equal to negative sine half times 2j over root 3 and e to the negative root 3 over 2. Wow, this is the very answer for our integral I. Wow, what a integral. Well, it's nice, very good. I hope you like it. Thank you.